Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about the diagonal properties of rectangles. And the two properties we're going to look at is the diagonals of a rectangle bisect each other, which in our diagram, that means this. PN and NL are the diagonals of this rectangle. And since they are bisected, we can say that this segment is going to be congruent to this segment. So MQ is congruent to QL. And then that PQ is congruent to QN. Now, another property of the diagonals is that they are also congruent. So since these diagonals are congruent, the bisections are going to be congruent as well, which makes PQ, QN, QL, and MQ all equal to each other. So all those segments in the middle of the rectangle are going to be congruent. Now, we want to look at this diagram and find the given information here down at the bottom left. And we're given this information up at the top. And angle MQP is 40 degrees. So let's go ahead and put that in there. MQP is 40 degrees. The first angle we're looking to find is MQN. So that'd be this angle here. Since we know that this entire thing is equal to 180, so we're going to take 180 minus 40 to get MQN, which is actually 140 degrees. Then the second angle we're looking for is MPQ. So MPQ is going to be this angle here. And as we've already said, we know that the triangle MQP here is going to be isosceles because we knew that this side was congruent to that side. Now, if this is an isosceles triangle, then the base angles are going to be congruent. And that is going to make each of these angles 70 degrees. So down here, we're going to put 70 degrees. And then the next angle, QPL. Well, QPL is this angle right here. And we know that the entire angle from here to here is a 90-degree angle. That's one of the definitions of a rectangle, or the definition of a rectangle. And so we would essentially take 90 minus 70, which is going to give us 20 degrees. Next, let's look at defining the segments. And we know that MN is 20. So here, this segment up here is 20. And we want to look to use our trigonometry ratios for right triangles to solve for these side lengths. So I went ahead and created a triangle here, MPQ, which is a right triangle. And we know that MN is 20. So if we're trying to find MP, we can say MP is X and write a trig ratio to solve for X. So here I'd probably use the tangent. So tangent of 70 is going to be equal to 20 over X. And to solve for X here, you would multiply by X on both sides and then divide by tangent 70. So 20 divided by tangent 70. And that makes 7.27. So here we can put 7.27 for MP. Let's move this over a little bit. And the next one, we have PN. And PN is the hypotenuse of this triangle, so we're just going to call that Y. And here I would probably use cosine. So cosine of 20 is going to be equal to 20 over Y. Now, do not confuse the two 20s here. The 20 inside the parentheses is referring to the 20 degrees in the triangle. So the adjacent, cosine is adjacent leg over hypotenuse. And again, you would multiply both sides by y and then divide by cosine 20. So you'd have 20 divided by cosine 20. And that's going to give us a PN is 21.28. And then lastly, QL. Well, QL is going to be this small segment here, which is going to be half of the entire segment ML. So it's going to be half of ML. But we also know that the diagonals are congruent. So PN is going to be the same as ML. So really, we can say that QL is going to be half of PN. So to find QL, you just take half of 21.28, which will be 10.64. So 10.64. And this concludes our video on rectangles.